Hello, geometry class, and welcome to another lesson in geometry. We have moved on to chapter 7, and we are in section 7-1, and this is all about ratios and proportions. So let's go ahead and jump in so we can talk about what these mean. So first of all, what is a ratio? You've used ratios before, but in technical terms, the definition of a ratio is a relationship between two numbers by division. So these can be written in many ways. There's three main ways that we're going to write proportions. One that we will tend to favor, which is a fraction. So for example, a proportion might be 2/7 because notice this fraction bar means division. But we could also write this as 2:7. These two things mean the same thing. It's comparing two numbers by division. And then we can write this one final way, and it would be 2, and then the word TO2, and then 7. All of these mean a ratio of 2:7. This is 2:7, 2:7, and 2:7. All of those mean the same thing. So let's practice writing proportions with a couple examples. It says, what is the ratio of ampersands to percentages? So we are comparing how many of these symbols I have to how many of these. So first of all, I have 3 of these guys, so I'm just going to put 3 in parentheses so I know how many there are. And then I have 6 of these. 1, 2, 3, 4, 5, 6. I am comparing the and mark to the percentage mark, which means the number representing how many these are needs to come before the number representing these. It is 3, 2, 6, or 3:6. But what I want you to notice is that this can be reduced. 3 and 6 have a common factor of 3 in them. So this is actually going to be 1:2, and that's my final answer. We have another example. It says Kyle is 150 pounds and Kendra is 130 pounds. What is the ratio of Kyle's weight to Kendra's weight? All right, so Kyle is 150, Kendra is 130. I want to compare Kyle to Kendra. So Kyle's number is going to come first, and then it will be Kendra. So it's going to be 150 to 130. But both of these have a factor of 10 in them. So that means I can distribute or factor that out, I should say. So this is actually going to become 15 to 13 for my final answer. Now, if you don't like writing it with a colon, then you can also write it as 15/13. And that also works. Both of these are the same answer. They're just written in a different format. For example C, it says a model train car is 6 inches long and a real train car is 30 feet long. What is the ratio of the model train length to the real life train length? So I want to do model and then to real life. That's the format I want to put this in. Now let's reread this. It says a model train car is 6 inches long and a real train car is 30 feet long. I'm hoping that you are noticing a particular detail. 6 inches, 30 feet. These are not the same unit. When I'm making ratios, I should use the same unit. So this 30 right here is actually going to be converted into inches. I would consider that to be the easiest way. So I'm going to take 30 times 12. I'm just converting it. And that's going to get me 360 inches. So now I can say 6 inches to 360. So I'm going to put 6 over 360. That does reduce by a factor of 6. So this is now 1 over 60. And there you have it. Those are some examples of how you would simply write a ratio out. And remember, a ratio is comparing two quantities or two values via division. Now, what is a proportion? Sometimes people use the words proportion and ratio interchangeably, but that's not correct. They're not the same thing. A proportion is when you have two ratios, but they are equivalent. So when two ratios or fractions are equivalent. So we're going to work through how to solve some of these. For example 2, it is how do you solve a proportion? Notice I have a fraction equal to a fraction, but fractions are just ratios. So I have a ratio equal to a ratio. When you have two fractions with an equal sign in the middle, you are going to solve that by cross multiplication. Please keep in mind, though, that it has to have an equal sign in the middle, so that's important. All right, so how do you cross multiply? Well, look at your x and your 3. Notice how they are opposite from one another, so I'm going to multiply those together. I have 3x. Then I put my equal sign. And then I have 10 times 15. Well, 10 times 15 is 150. At this point, now my equation is all in one line, and it should be a lot easier to solve for you. So I have 3x is equal to 150. I'm going to divide by 3 on both sides. X is going to equal 50. Let's do the same thing with the next example. I have 5 over m minus 3 is equal to 10 over m. The most important part is to not let this kind of throw you off the fact that you have multiple variables, and go ahead and put parentheses around that guy. Something that you learned way back in like one of the first sections of Algebra 1 and pre-algebra likely is when you have a fraction bar, it works as a grouping symbol. So I just want to keep this m plus 3 together. So I'm going to cross multiply this guy because I have two fractions equal to each other. And I have 5 times m, or 5m, is equal to, then I have 10 times m minus 3. So I'm going to write that out like this, 10 times m minus 3. I'm writing it like this because a lot of times people forget to distribute this 10 to everything in the parentheses. So if I write it out, it's a little bit easier to see that. So let's distribute. I have 5m is equal to 10m minus 30. Now I want to get the variables all together, so I'm going to subtract 10m from both sides. That gets me negative 5m is equal to negative 30. Now I want to get rid of this negative 5. Sometimes people say add 5. No, you're going to divide by negative 5 because when a number is right next to a variable, that means multiplication. To get rid of multiplication, I divide. So divide by negative 5, and I get m is equal to positive 6 because a negative divided by a negative is a positive. All right, let's flip this note page over. And we just have 2 more examples. Next, we have the dreaded word problem. Solving a proportion word problem. So let's just read through this and see what it says. It says, last year, the middle school dance had 90 kids attend, and it cost $230 to throw the event. If this year they expect to have 110 kids attend the dance, what should they budget for the cost of the event? Round to the nearest dollar. Alrighty. We have a proportion. And when you have proportions, you have two quantities that you're comparing to each other. So let's identify what those quantities are. We're comparing how many kids attended to the cost. And then down here, we're comparing again how many kids attended, but now we need to figure out what the new projected cost would be. So those are my comparisons. So I am going to just kind of set up what I call a skeleton equation, so I know how I'm going to set this up. And with proportions, there is a very important rule. Keep it consistent. That is your rule, and I'm going to put a little burst around it because it's important. With proportions, you have to make the two fractions match in the way you set them up. What I mean by that is this. I'm going to put kids over cost. That's how I'm going to set up my proportion. So my first pairing is 90 kids to $230. That's kids over cost. So that's 90 over 230 is equal to, now I need to set up my second proportion, and I have to do kids to cost again. Kids over cost, kids over cost, kids over cost. Now I have 110 kids, so that's going on top. But I don't know what the cost is, so I'm just going to put C for that variable because that's what I'm trying to figure out. Okay, so now I'm ready to solve. This is a proportion where I have two ratios equal to each other. To solve a proportion, you cross multiply. Okay, so that gets me 90 times C is equal to, and then what is 230 times 110? That is going to get me 25,300. Now you might be thinking, that's ridiculous, that's a huge number. Well, we just multiplied two pretty big numbers together. Okay, now I want to isolate the C the rest of the way, so I'm going to divide by 90. And when I put that into the calculator and then round to the nearest dollar, because those were the directions, I am going to have a projected cost of $282. So we expect that party to cost $282. So the main thing with word problems is to keep them consistent and to know what two quantities you're comparing. Okay, we have one more example. So it says in the diagram, x over 10 is equal to y over 9. What ratio completes the equivalent proportion x over y equals, and then it's blank over blank. We're trying to figure out what these two values are. Use one of the properties of proportions to justify your answers. Okay, what I want you to notice, this is the way I think about it, and this is the way that I consider it to be the easiest, but I will show you the technical way as well. Notice my first proportion that they set up. They had the top left over the top right, and then they had the bottom left over the bottom right. So notice, left over right, left over right. X over 10, y over 9. X was the left part, 10 was the right part, so left and right, and then y was the left part again, and 9 was the right part. So they kept that proportion consistent. We can also think of that with my next ratio as well. So here they have top over bottom, so I could also say top over bottom. Or 10 over 9. So my equation or my proportion would be x over y is equal to 10 over 9. This is what makes sense to me. I look at my image or I look at my problem and I say just keep it the same. If they went top over bottom, then I go top over bottom again. If I go left over right, then I go left over right again. Or it could be right over left, right over left. So that's how I think about it. But there is a rule in proportions that I would like to show you. And it is a property. And it basically says this. If you have A over B is equal to X over Y, and this is just a generic thing, you are allowed to switch these two guys and get the same thing. So that is the same as A over X is equal to B over Y. And notice that's actually what we did up here in this example. So I took this 10 and this Y and I swapped their places to get this down here. So that is just a property of proportions that I wanted to introduce you to. But all it wanted us to do is write an equivalent proportion, which we did. So we have solved that problem. Use whatever strategy makes most sense to you. That's it for section 7-1. I hope you have a great night, and I'll see you later.